Hello and welcome to our webinar entitled Data Science, Effective Use Cases and ROI. There are people still joining us, but we want to be respectful for everyone's time, so let's go ahead and get started. First of all, I'd like to say thank you for taking the time to join us for the webinar today. And I have a couple of quick notes for us before we dive in. As we move through the webinar, everyone but the presenters will be on mute, but we do encourage you to send questions and comments using the chat function on your screen. We'll have a Q&A segment at the end of the webinar, and that's when all those questions and comments will be answered and discussed. Now, the point of these webinars is to be informative and educational in nature. So we have no intention of pivoting to some hard sales strategy here, but I would like to introduce our speakers to you and give you a brief overview about this sponsor of the webinar, TechGenies. Slide 2, please.
It's there.
Our presenters who have a long history and wealth of knowledge in data science and a host of related technology experience that touches almost every industry vertical you can imagine. Bharat Sharma is our head of data science practice, and Ryan Boverman is Chief Technology Officer at TechGenies. Next slide. And TechGenies is headquartered in Richardson, Texas, in the Innovation Corridor, which is just north of Dallas. We work with everyone from startups seeking end-to-end technology enablement to large enterprises looking to bridge critical skills gaps, of course, quickly and cost effectively, to mid-size operations looking for defined deliverables, and we develop custom solutions that are every bit as unique as the businesses they serve. So whether you need to augment your current IT staff, an entire team, or your organization has fixed deliverables, TechGenies has the skills and expertise to bring those wishes to life. So let's take a look at the agenda for what we'll be discussing today. We will talk about, of course, what is data science, and are you getting the most from your data? Whether you're currently involved in data science in your organization or not. Why does your business need data science? We'll look at some use cases, some case studies, and we'll have that question and answer portion of the webinar that we talked about earlier. So now I have the privilege of handing this webinar over to our presenters. Ladies and gentlemen, I give you Ryan Boverman and Bharat Sharma.
Thanks, y'all. So it's really nice to meet you. Thanks for attending today. So again, I'm Ryan Boverman. I'm the CTO with TechGenies, and my partner in crime is Bharat Sharma. He's our head of data science. So we love this field and this topic, and I don't think there's a conversation that Bharat and I do not have where we just we really talk endlessly about this topic. There's just so much variety, and potentially this is webinar 1 of many more that would follow, because it's just such a wide array of a topic that we just love. So I think with that, we'll start with just some key terms. You might know some of these, or you might have heard some of these, but just want to get through a few of these and what they mean behind the scenes, and we'll use these interchangeably as well. And then I've heard I use acronyms all the time, so in case I do that too much here, you can you'll know what I'm talking about. All right, so again, inside of the whole package of data science, we'll start with artificial intelligence, right? Everyone probably knows what that one is. That's some level of intelligence, whether it's in a robot format or algorithm format, or some type of entity that is there that has some sort of intelligent factor to it. And then behind the scenes of artificial intelligence is the algorithms, right? That's the most important part of artificial intelligence, is just a conundrum of algorithms behind the scenes, making all of this work. So that's really the key essential part of all of this. And then machine learning. Bharat, why don't you take us through what your definition might be of machine learning and what that means?
So hi all, this is Bharat here, the head of data science TechGenies. So if I go for these terminologies, AI is basically something that is replicate the human intelligence, human intelligence we can make machine to replicate the human intelligence is something artificial intelligence. It's very broad level definition, but if you go to the ML machine learning, it's a subset of the AI. So it uses the algorithms, mathematical models, uh, and it takes the input. So what is the input? Input is the data. So like, a child which has no knowledge or something, that we feed some data and then, that the child keeps on learning. The same thing machine learning happens. So we have algorithm, we have the data, and we'll keep on training the data with machine learning algorithms, and we keep on improving the accuracy. So the same concept is applied here. So as I said, the input here is the data. So the data is used. Now we have almost all the companies, all the verticals like going digital, they have their own website, they have their own mobile apps. So they have a lot of data. So this data can be organized somewhere in the cloud, in some repository. For that, we have something called data lakes. So this is for the used data, something like, terabyte or petabyte of data. We can organize the data. Data could be both structured and semi-structured. So something like, your Excel file or your CSV file, we have something like tabular data, that's structured data. But we could have unstructured data also, something like emails or text data or some Twitter tweets, comments, or some Facebook posts. These are all, or images or videos. These are unstructured data.
Yeah, very
So
nice.
all,
Thank you for that.
So
Just
all this can be all.
yeah, sorry, bro. So you might have heard the term data warehousing a lot. That tends to be, not in all cases, but tends to be more structured data, where data laking is more of the, what Bharat was referring to, unstructured data, and just a massive amount of data for the machine learning and these algorithms to really take form of. So didn't put data warehousing on there, but just wanted to contrast that with data lakes. So Bharat, walk us through then what your impression of predictive and prescriptive analytics may be.
Yeah, so we have predictive and prescriptive, but there are two more type of analytics. We call it a descriptive and diagnostic. So first I would like to go for the descriptive analytics. So descriptive analytics takes the data, historical data, and tells what happened. So it is just telling you what is happening with, but in diagnostic analysis, it tells why it happened. So that's the difference between descriptive and diagnostic. But predictive analytics is something what is going to happen in future. So the typical use case of predictive analytics is something like if we're doing some forecasting of sales, or if we're doing some forecasting of stocks. So that is our predictive analytics, or forecasting of attrition in a company, or so that is the predictive analytics. Having done all that, there is something called prescriptive analytics. So it tells what action you need to take to improve your, what action you need to take. So the output of prescriptive analytics is the actionable items. So your organization takes the actionable items. For example, your attrition is going high, and then predictive analytics tells these are the variables because of it's going high, and then prescriptive analytics can tell these are the actions you need to take. So this is what prescriptive analytics. It's more of a recommendation in nature.
Right, perfect. Thank you for that. All right, rounding out a few more key terms. So let's get really complex here now with neural networks and deep learning especially. So, neural networks, that's how the human brain works. It's essentially a very sophisticated, complex neural network. So, this area has a very lot of similarities to how human brains are learning. And then deep learning is really the neural networks in action. So Bharat, let's kind of trans over to you again about these two areas, and maybe even bring into the cognitive computing models as well on how all these come together.
So again, deep learning is a subset of machine learning. So deep learning uses a neural network. So why we call it a deep, that I'll come later, but neural network, so we have something called cells in brain. So we call it a neurons, and we have different neurons and they are connected with each other. We call it as synaptic connections. So similar, in brain, it's like randomly they are connected, but in neural network, we have different layers. So layer 1, 2, 3, 4, 5, it depends on that how many layers you want to add. And that is the art of data scientists to design a perfect neural network for good prediction. More than a science, it's an art. So you can have different neurons at each layer. So let's say I have 5 layers, so I'll have different number of neurons at each layer, and layer 1 will be connected to layer 2, 2 will be connected to 3, and each neuron in these two adjacent layer connect with each other. So in first neuron I have m neurons, in second layer I have n neurons, so I will be having m into n connection. So that's why it can go deep, like you can have like 10 layers, so it becomes a deep neural network. And each neuron will have, you can have like hundreds of neurons in each neural network. So the computation becomes very, very expensive. That's what they use it. And the applications is mainly for in very applications where, computation is very expensive, something like image classifications, image recognitions. So that's the neural
My keyboard's
network.
going crazy. Sorry about that.
And cognitive computing is a term coined by IBM. They have some machine called Watson. So it's again the same thing, like, cognitive computing, they have their own deep neural network, and it's just a terminology coined by IBM for for this Watson machine. And model is something that we develop. So we have a data, we have an algorithm, we train the data, we train the algorithm with the data, and we save something which is called model. Once we are done with the training, that model is deployed in the network, in your production setup, and it is used for prediction or prescriptive analytics or diagnostic analysis, descriptive or anything like that. So the whole the process of data scientists is to keep on training the model, improving the quality and accuracy, and going live with that.
Perfect. Perfect. Thank you for that. So think of these neural networks, right? How do you teach a 2-year-old that, hey, if you step on Legos, it's probably going to hurt, right? Those are the models that we would build for the neural network. So, and provide data and input. Hey, something like a Lego is also going to hurt just as bad, right? It's just, just the same type of learning mechanism for this area. The last one here, the key term, probably not going to talk a lot about it today, but RPA is a term you might have heard, robotic process automation. That's a little bit less about data science. It's more about performing work. That's why it's a kind of a robot that does it. But advanced RPA does use all of these areas of artificial intelligence and machine learning, because if they can really take the thought process, not just the doing of the work, but thinking about the ramifications of the work, right? That's where really intelligent robots come into place. Okay, so I think we're done with key terms. Hopefully we're at least kind of on the same playing field now. So what are some challenges we see? Well, modern business, 5 years ago, it used to be they didn't have enough data, right? What if we only had the data, we could really make better decisions. And now it's kind of the other problem. We almost are overwhelmed with too much data, and there's almost too much data for me to wrap my head around at this point in time. So how do I know what data is the most meaningful to me to really impact what I'm intending to do with my business, or what's my sales price going to be, or hey, it's the Christmas holidays, how do I get the most out of the e-commerce promotions that I'm trying to do? So we're just all overwhelmed with the amount of data that we need, and we need help, right? We're at a point where we've got too much data to assemble. We need this area that we're all here on this webinar today to just make sense of it. How can I make heads or tails of all of this data that's coming around? So enter the solution of data science. So Bharat, you're the resident expert in data science. Why don't you walk us through kind of the solution to the problem that I just teed up? Oh, you're on mute. It looks like you're on mute, Bharat. There you go.
Yeah, so again, this data science is telling a story about data, whether it's structured or unstructured data, and it will do some data insights. So what we do, I explained earlier, we have some historical data and we select our model and we train we train the model and we save it. And once this model is saved with good accuracy and quality, and then we do our forecasting and we do our predictive and prescriptive analytics with that. And this is the job of the data scientist. And data science is data scientist, the guy who knows the algorithms, who knows the mathematics, and who knows the domain also. So the knowledge of domain is also very much important in that. Yeah. And this is what this data science does. It takes the data and it does actually does the automation of human intelligence, and that's how any industry can automate their processes, their tasks, and their decision making capabilities with the help of data science.
Perfect. I liked one of the words you used there in that segment and the other segment. There is a lot of science to this, right? There's a lot of different categories. There's statistics, there's analytics, there's certainly, the basic business, nuts and bolts of business, and bringing all this data and assembling all the models, but it's also a lot of art to this as well. There's a lot of art in thinking outside the box on, what are the exponential leaps that really get my business to the next level, and being able to look at this data through ways that I've never even thought of before, right? If we train these models in just the right way, we'll get answers to questions we didn't even know to ask based on the mass amount of data that we might have access to now. So great job there. Okay, so kind of getting back to the nuts and bolts of the foundational element of a lot of this stuff, which is the data itself, right? Bad data. The studies are showing $600 billion annually of costing US businesses just in bad data. So we need to clean up a lot of our data. And then another study showing that just a 10% increase in just accessibility or greater accessibility to the data we probably already have and just don't have it in a usable format, we could see $65 million of additional net income to the typical Fortune 1000 company, right? So they have all this data, they just don't know what to do with it really. And there's probably 65 million of net income just waiting to be seen and recognized if they could make something of that data. And the sad part of all this, with 65 million potentially on the line here, less than 0.5% or 0.5% of all the data we create is ever actually used. And that's just a sad state, right? So again, enter this practice to really enable us to get our firms and our companies to the next level. I just really love this stuff. Okay, so bringing it back to an ROI, right? That's the whole point of doing this, is there's some kind of return on tapping into that 65 million, right? So we could do data science around the effect on cost, right? What does it cost just to operate our business in terms of supply chains, in terms of people's and salaries, the cost of retention, recruiting, the cost of building something, and the cost of retaining a customer, right? What does that do? And then transverse that with the effect on revenue, right? What are all the revenue projections, and what are the kind of going to the prescriptive analytics, those kind of things. What might happen, and what are the models we build to get more of that 65 million is just waiting to be taken. Efficiency on our team and our enterprises, right? Are we excellent at what we do? Are we just getting by, right? Those are kind of more the low-hanging fruits, but then getting it to the SLA level that we're looking at and getting that to the next level, right? Data science is right for that area. Intelligence on our competition. What are they doing, right? As long as we can get access to the data and modeling what our competitors are doing, we're in the driver's seat then on tapping into that unused money that's just sitting there with just better data science at our disposal. Speed to implementation on any one of our ideas, right? Where if we had access to being able to aggregate the amount of data and to really clean the data up instead of the bad data, right? Our speed to implementation should be exponential to what it could possibly be today. Transaction costs, right? In terms of doing business from A to Z, right? What does it cost us now with better speed and accurate data, right? We should be seeing that lower, which means our revenues are going up. And then opportunity costs, right? What are those areas that we're not tapping into because we haven't really even looked at those areas or realized that's something we should be able to get into, right? This is where all this artificial intelligence and machine learning, they're learning what we do and what we want to accomplish and providing us now with the opportunities that may not have even been on our radar before. So anyway, this slide is what really excites me about this, just the potential here of amazing accomplishments that we can do with this practice is just, it just floors me. All right, so data science and how does it work? Let's get it down to brass tacks about how it actually works. Bharat, why don't you take this slide, walk us through, feel free to use what's on the slide, of course, but let's maybe hear a life in the day of Bharat and what you do in this world of data science to bring it all home.
So for anything, we identify the use case, what is the use case, and then we find out how are the data science or algorithms are going to solve this problem. And we need a lot of domain knowledge in that, finding the data sources. So we cannot take any data because that becomes like a noise for us. But we have to check the completeness of the data, whether this data set is good enough or these data points are good enough to tell the story. So we need a lot of domain knowledge for this, as for identifying the data sources. And data could be, as I said, could be structured or unstructured data also. So that's one thing. Then after identifying the data sources, we need to aggregate data. So maybe we have some tabular data, some CSV data, but we have something like alarm data, which is coming in the text format. Let's just say we are doing automation of IT managed services, all through data science, we are finding the problem with the IT network. So we can find out a lot of alarms are also coming. So they are coming in the logs. So we have to extract the features from those data and we have to aggregate. And we have some different type of tabular data. After doing this, we identify the data source and we do basic visualization and analytics. So it will be very high level business dashboard where, anybody can go and have a look at the data, select the data sources, do different type of visualization. It could be some line chart, it should be graph chart, and it should be a bit of basic analytics. Then comes our machine learning and artificial intelligence. We use the data set, we train the model, and we develop a model for predictive and prescriptive analytics. And we identify the models and we go live with that. And we use that model for our real-time prediction kind of applications.
Perfect. Thank
so
you.
that's how, and we keep on improving the accuracy. That the task happens in the background. Once we identify a new model with the better accuracy, we replace the previous model with the new one. And so that's how the entire life cycle of data science project looks like.
Awesome. Thank you for that walkthrough. Let me ask you a question here. How the models that you're doing, the initial models and, putting something into production, how often do you think that, data scientists get it right the first time, second time, third time, versus, this is learning and, oh, that didn't actually result in what I thought. I have to write a new model. How often do you think it's success and fails?
So that's the whole art of selecting a right model. We select a model and we say, okay, the accuracy is not good. Then we try different algorithms. Maybe the accuracy improves, but still it's not good enough. Then we identify whether we need to add new data set and improve the accuracy. And there are other techniques to improve that accuracy. Let's say we don't have the data. We don't have data for improving the accuracy. So we do the data augmentations. We generate our own data with the simulation, and then we improve the accuracy. And this is how we improve. And the end goal is that whatever the accuracy and whatever accuracy is acceptable, we should stick to it, and we should deploy the model only once we achieve it.
Yeah. Would you say that the accuracy of the data is probably your biggest hurdle to coming up with the best set of models? The amount of data there is and then how clean the data is that kind of
Yes, yes.
Not the
So
smartest way to think about it.
accessing the data, cleaning the data is like, 80% of the work, and the model development comes to the 10%. So the typical day of data scientist looks like cleaning the data day in and day out and experimenting a lot of things there.
Yeah, garbage in, garbage out. So yeah,
Yes, yes.
I feel you there. I feel you there. All righty. Okay, so we've walked through, let's see, basic concepts. We've got, why are we even talking about this? And we've got some kind of the basic in the life of a data science. What areas can this practice be applicable, right? And it's, the short answer is every area can be sought out by data science. Here's some of the ones that I thought would probably be most interesting. Fraud and risk detection, right? I don't know about y'all, but I get a new credit card every 2 months, it seems like, because somebody's hacked my account. So the use rate of fraud and risk detection, those are all perfect cases for data science to be applicable. Healthcare, certainly, especially in a COVID world, and just health of our society in general, right? Healthcare is a huge part of data science. The speed of how a COVID vaccine was even brought to fruition is, a lot of it can be attributed to data science. Banking, certainly, right? There's so many areas of banking that are just perfectly ripe for this area. And then you get more into the traditional, e-commerce, targeted retail, targeted advertising, drip campaigns, those kind of things. A lot of those are already being conducted by artificial intelligence, especially the larger type companies like the Amazons out there, right? There's everything they do is pretty much because of this practice, because they have access to data at scale, and then they've got a lot of the technologies to really sift through these things to really always position their product to a next level. Product recommendations. Then you get to more of the kind of on the floor shop operations like manufacturing, just core manufacturing, right? Robots are building a lot of things right now, so they can't really do that without these data science practices. And operational excellence is anything we're actually building, manufacturing, or the way we're just conducting business operations, certainly applicable for data science. Gaming, right? A lot of the games that are coming out right now, right? The human didn't actually write the end of the game. It's evolving as you're interacting with it. So I've got my Oculus 2 now. I got that for Christmas, and who knows what the end of that game is going to be, because it's going to be tailor-made to, one, how good I am, what I'm interested in, and what I want to do on that. So certainly it's applicable for gaming. And then advanced image and speech recognition, right? These are all just perfect ways of speed of operations and all this recognition areas that machines are just perfectly made to do, and data science is perfectly applicable. Bharat, is there anything kind of categorically that you think I might have missed here that you think we should probably talk about?
We have given some example of few of the vertical, but the fact is that data science, artificial intelligence can be applied anywhere. There is no vertical where we cannot apply data science and artificial intelligence.
Yeah, I agree with that. Yeah,
that's the bigger point.
Yeah, perfectly said. All righty. Okay, we'll take a stop here for a second. Jonathan's got a pop quiz for everyone. Jonathan.
Sure. So we've got a little pop quiz here, and a little joke. I need some data from an unreachable guy named Ed. What should I do? Just make up a bunch of data like everyone else does. Everyone else does that? Are you doubting my data?
Right.
So if you could tell us what cartoon this is in the chat, what this is, the name of the cartoon strip. The first 5 people to answer the question will get a free code review. So if you have software and application, anything like that, and you'd like a free complimentary code review, code audit from TechGenies, please chime in.
All right, I could totally answer this question. By the way, this is really funny. I have seriously been in board meetings and exec meetings where somebody says something very similar to this line. So this one really hit home about let's just generate the data, right? Let's just make it up as we go. Nobody else has anything better anyways. So this really hit home. All righty. Okay, so going back to use cases, right? Wanted to drill in just a little bit more in these areas. So we did talk about fraud and risk detection there. Jonathan, maybe this is something you can actually speak to as our marketing expert, right? Targeted advertising, drip campaigning. This world of data science, I know is really changing and evolving the digital marketing space. So I don't know if you want to make a comment or two about what possibilities you could even see with this area in terms of your field.
Absolutely. So the more data you put in, the more information you put into a system, the stronger and more accurate recommendation systems become, and systems for targeting and retargeting audiences for things like Facebook ads. You can put in, you can upload like a CSV spreadsheet, like Bharat was talking about earlier with tabular data. And you can tell Facebook that you would like to target a lookalike audience. So you can even not know exactly who you're wanting to target, but you've got an audience already set that kind of meets certain criteria for you. You can upload that, and through a process of AI and machine learning, they'll alter the course of who those ads are shown to based on what you've fed into the system. So really interesting, and not only Facebook is doing it, but it's kind of across the board with advertisers picking up like everyone else is doing these days, and getting on board with data science.
Perfect. Thank you for that. That was unplugged and unscripted, so I appreciate you jumping in there. All right, so autonomous areas, right? These self-driving vehicles are kind of everywhere now. I've actually seen a couple of them, and they're really pretty cool, but it's not even possible without the amount of data to process as fast as they can to be able to make the right decisions that we kind of take for granted as human beings when we drive. Again, I mentioned the vaccine modeling. That was, in any COVID study you've seen, right? The amount of data that machines were running to crunch the models on that is just astounding. And then you put any other vaccine, right? It's the year of COVID, so that's what we're talking about. But any other vaccine you've ever heard of in the last couple of years has really had a huge stake with data science coming to fruition. In terms of product optimizations and manufacturing, I was kind of mentioning robots building a lot of things, right? So cars, and for instance, while we're on the cars and self-driving, right? A lot of the robots are making decisions on the fly about, doing the quality checks that it needs for products to come together, and the data from the last set of vehicles that just went out in terms of making those excellent, right? And then these are machines that never really sleep. They don't take vacations. They're always going, and they have access to have their own networks now, neural networks, to really enhance the machine line as they're going along, really with just the models that data scientists put into place, and putting that machine learning together. So it's just really an exciting time. I really think we're at the cusp of these type of areas being fundamentally different than they were, say, a decade ago, and thinking about what all of these areas that I've got on the screen here could look like in the coming decade. It's just the potential is fantastic. All right, so where are we going to? I guess I just kind of tease this a little bit. So where's the future of this practice going? Right, a lot of it is just understanding customers. Bharat mentioned this, and what he was saying was challenging, and what he saw coming too is knowing basic profile data, right? Jonathan spoke to it as well in terms of digital marketing, right? If we can understand our customers and predict their behaviors, I mean, it's good for them as well, right? We're not just selling them stuff they don't really need. It's stuff that they would need on the time that they would need it as well. So it really is good for everyone as well, right? Our ability to communicate our brand story just gets that much more powerful as we're relating to everyone better, certainly our customers. I mean, as Bharat was telling us, right, this applies to any sector, right? It's just the ideas probably haven't gotten there yet. And that's really why we're doing this call, is to do, what are the ideas that we haven't tapped into, because we all need each other right now, because this technology is here. It's pretty reasonable and affordable now. So what are the ideas that we all have to come together, because it is so accessible? Just kind of a little quote here. The business world is shifting fundamentally with artificial and ML. The amount of prospects that we as TechGenies talk to, and then the amount of solicitations I even get about this area with our company, it's compounding exponentially in this world, right? This is the now. It's not really the future. The future really is right now, and we're kind of predicting that the companies that enter into this world and embrace this world now, they're going to be the ones leapfrogging their competition, because they're just going to have, they're going to have data and insights and learnings that nobody else even dreamed of, because they didn't do these things. Bharat, in terms of the future and how you're seeing it, what else can you add here for, for what's in your sights?
Now we have only mobile and mobile connected, and but future with the IoT, Internet of Things, there will be 20 billion devices connected. So it's not like your mobile or laptop which is connected to network. It could be your car, it could be your fridge, or it could be anything that's connected, and it could be your healthcare devices. So you could have a heart rate monitor or your pulse or something. So there will be the network of devices, and there's going to be huge explosion of data, and the security also plays a big role, and data science again can solve the real-time security challenges of all these devices. So even with the explosion of the data, we'll have the security issues, but again the data science will come into the play and can solve these problems. And all these security problems have to be solved in the real time, whether it's a fraud detection or any a network attack or any kind of thing. It has to be the real time. So we have the computations now. So the point is that there is for machine learning, these algorithms are not new. They have been like developed 4 decades back. The only two things that were missing 4 decades back is that there wasn't any enough data, there wasn't any enough computation. Now we have both. We have data, we have the computation, we have all the cloud companies, and we don't need to set up our own IT infrastructure for any data science. We can, on the subscription basis, we can take these IT companies. And so because of these two factors, the data science and artificial intelligence plays very big role in the future. And no industry, you cannot afford, you cannot go ahead without data science as a technology in your organization.
That's really great points. I'm really glad you mentioned the security aspect, and then the advent of the cloud is really what made all of this so accessible now, right? And there's 2 or 3 or 4 really good cloud providers that make it pretty cheap for whatever companies to tap into with really good technologies, and that has made it so accessible, and really, that's why the data science, it's going to be just like sales, marketing. You've got to have a data science area to probably survive in the next 10 years, right? Because your competitors certainly will. Great points. All right, let's talk about a little bit of ethics and humanity considerations in this area. We really can't talk about data science and machine learning and neural networks without speaking about this topic. And I hope we never get to that point where we're not thinking about it. But the knowing what is right and knowing what is wrong that's not really machines aren't really capable of doing that, right? That's what humans do. That's what we are gifted with. And the models that we build, the networks that we build, we're the ones telling the machines what to do. I really asked Jonathan for that Terminator picture on here, and he just wouldn't do it. But we've all seen that Terminator movie, and that's what happens when ethics and humanity kind of go the wrong way, right? So it's what we're doing right now. With the great power comes a lot of great responsibility as well, right? So it is up to us as we're embracing this exciting world. I'm as pumped up as anyone about it, but I guarantee you, everything we're doing, everything we're conversation, absolutely has the ethics and humanity considerations in here, because it's not responsible to not do that, right? And it is up to us to teach our children. It is also up to us to teach our machines of what to do and what is right and what is wrong and what is the frame and what is the boundary, right? So anyway, there's just a whole lot here, right? Well, what are the ethical challenges in data science? I guess, Bharat, let me ask you that. What have you seen ethical challenges, or have you worked with clients that maybe weren't as ethically minded as you might be?
Yeah, there could be ethical challenges, especially access of the data regarding, because there are a lot of security issues involved with the data, and they really cannot share a lot of data with that. So these are the challenges, because any companies, any company, data is they have to make sure that their data is secure. So we have faced a lot of problem in accessing the data because of these challenges. Yes.
Perfect. Awesome. Thank you for that. Yeah. So anyway, just kind of keep this in mind as you're dipping into this world with us. All right. Some case studies just that we have experience with in our kind of our community here. We have conducted, NLP is I should have put that on the key terms, natural language processing, right? The ability to turn speech into actual command, right? So NLP technology for recognition, right? Deep learning, right? We went through that on the key terms, right? Anomaly detection, iris recognition, image recognition, right? All these recognition things that really made automating business fantastic, right? And then automation of telecom, managed services. We have fault management, configuration management, performance management. They're all using machine learning to do these areas of managed services. RPA, right? Those robots that do kind of just work all day. We've done that in the financial services areas as well, automating quite a bit of functionality for areas. And then a recommendation engine for videos and streaming applications, right? That's a huge part of knowing your customer and giving them kind of what's customized and tailored to them, and having that data for recommending those areas. So I went really fast there, right? But I guess, Bharat, is there anything on here or maybe some areas of a case study that you think will be coming down the pipe anytime soon, or anything you wanted to mention?
We have been working a lot on HR analytics also. So that's
Good point.
Those case studies we have done. And we'll be building a lot of new robots in RPA. So that's the future in TechGenies.
Good one. Perfect. All right. Well, I think we're really at the end of it, right? So we can be a partner here to the extent that you'd like. Reach out if you'd like to. We have expertise in this area. And then I just leaving with a few closing thoughts before we get to questions. So I love this quote: "Data is the new oil of the digital economy." Right? I just love that quote. It speaks for itself, right? And then, if data is the new oil, well, then that probably means artificial intelligence is the new electricity. So I love both of these quotes. They really encompass everything that we're excited about in this area, and hopefully that's shown through in this chat. And then I think, Jonathan, let's see what questions we may have.
Absolutely. And as we go through these questions, just keep in mind that you can still type questions into direct messages or to everyone in the chat. But we do have a few questions here. The first one is, what's the best technology stack for data science?
Oh, that's a tricky question. Bharat, you want to go? I'll let you go first, and then I'll chime in.
So we have used different technology stack for data science. We have used distributed computing also, where data set is used. So we use Apache Spark platform for distributed computing. But if the data set is not used, then we use the standard Python libraries for developing our model. So these are very standard basic Python library. For deep learning, we use TensorFlow. For image processing, there are some library for image processing also. So we have been using it. But it depends on the use case and the requirement. We can adapt to different technology stack.
Perfect. And I'll just add, we talked about this a little bit, but every cloud provider has pretty good technology in this area, right? You really can't go wrong, and Bharat is 100% correct. It depends is really the answer to that, but there's no shortage of very accessible technology. Python is obviously a lot of the glue that binds a lot of it together, but every cloud has really good technology.
Excellent. Okay. The next question here is an interesting one, and it's, how close is artificial intelligence to natural intelligence?
Ooh.
Yeah, so with the artificial intelligence, we are able to detect a lot of things like, cancer, different type of diseases. So the accuracy is pretty high. And if you take the example of some, Google Assistant or Alexa, their accuracy is pretty high. But again, it comes to the like common sense. So, common sense is something that we cannot solve using this machine learning algorithm. So that is something, artificial general intelligence is something, that the machine learning is not able to solve.
Yeah. Yeah, my 2 cents on this one is it depends. Sorry, I'm saying it depends a lot, but it is kind of true here as well. In terms of just executing a task, or let's put 5 pieces of data together and figure out the right path, right? Machines are actually ahead of what a human brain can do at this point in time already. But in terms of, what is right and wrong, what is common sense, right? I think that's where the natural intelligence probably still has it over, and hopefully always will have it over artificial intelligence. So I think, if you're dividing along those lines, we'll probably be pretty safe in terms of how close it is. And I think, in the next decade, we're going to see that, that the humans and natural intelligence are leading the way in terms of what is possible. What's an algorithm we should even consider? What's a neural network we should even consider? While the machines and the robots are doing the actual real work at the end of the day, while we're, the human mind is more about what if, what would happen, what might happen, and kind of coming up with those scenarios more.
Excellent. Yeah, I was thinking as you mentioned, Bharat, that one of the things that maybe AI is lagging on when it compares to natural intelligence is common sense, and well, some of us lack some of that sometimes too.
We all have at certain points, I'm sure.
That's true. Okay. So what is pricing like on data science projects on platforms like AWS or Azure?
The pricing is competitive. I mean, if you compare the pricing on AWS and Azure, they are almost similar because they compete with each other, and they provide almost all the functionality. But again, the pricing will keep on changing depending on your project size. So, for example, let's say I have to train a model for something like, terabyte of data or petabyte of data, or maybe it's image data, which is, very high in volume. So I need some GPU instances. So again, the pricing will change. But if it is a normal, simple data or some mega MB data or maybe GB data, then you can have a basic instance. So again, depending on the project, your pricing will change. But you can have any type of instance type, it is CPU or GPU, depending on your requirement for computations. So there are different options, and it's well mentioned on AWS pricing pages for each instance.
Yeah. So my 2 cents on this one is actually very similar. Probably in the tens to hundreds of dollars for a very small topic, and the thousands of dollars as you go up in terms of scale and compute power. And it's a tricky question, because is the question for what is my annual cost, or is it monthly cost, or is it kind of one model to execute one time? What's that cost? Which is, you're kind of getting into a more cloud economics kind of question. So it does depend again, but what the prices on all the cloud providers are published, and then you just kind of have to rationalize how much data and compute might you need to do with whatever you're trying to achieve.
That makes sense. Okay, here's another one. So speaking of ethics, in modern psychology, there's the concept of emotional intelligence. Is there anything like artificial emotional intelligence?
Yes.
So there are some research papers by MIT also, but it's only on the research level. So a lot of work again is happening on the research, AI community, but there is nothing like for the real industry use case for this as of now. So I really don't know how many years it will take, but yeah, definitely there is a lot of work happening on that front also.
If I may, so I before I entered the world of marketing and business, I was actually in the counseling world. So as a counselor, I remember seeing a demonstration of a product that came out where it was an interface with a computer, and the computer could read facial expressions and then respond based on what the interviewee had, or the client or patient had said to the system, based on their facial expressions, their voice, their volume, whether it was quaking or if it were very loud or panicked, the prosody of their speech. And it took all of these factors into consideration when it spit out a response or another question.
Yeah. My response to this question is yes, there's absolutely this concept. I don't think it's probably one of the better, more sophisticated areas of this practice so far, but it's absolutely under determination, right? And if you've done a click to chat with, say, Sprint or AT&T or whatever you're doing a click to chat with, right? You're talking to a robot 99% of the time. And I've noticed in the last year or two, they always say, how are you feeling today, Ryan? And I can tell it's a robot, but at least they're giving me the illusion that they care about how I'm doing today. And they're thanking me for calling in my time more than a human probably would do. So it's definitely something that's under consideration, but I would say it's yet to be refined. So I'm sure in the coming years, it's going to get better as our neural networks are getting better. But again, this is just like we're teaching some robot how to drive a car, we have to teach them how to be emotionally equipped because that's what humans are, emotional creatures, right? We just are, and that's a good thing. And the machines need to kind of catch up with us there.
Absolutely. So here's an interesting question on a different side of the spectrum. Should I be good in mathematics to work in data science?
Well, it helps.
So data science is a vast field. You can work in data science team as a domain expert also, and you can work as a programmer also. But if you really want to do typical algorithm design, machine learning, so yeah, mathematics plays a big role here. So it's good to have a good, and so right now it's very high level APIs. You can use it. It becomes like a black box for you, but what mathematical functions are computed by those APIs is something that to be a good data scientist you really need to be good at mathematics. Good at mathematics.
Yeah, I would agree with that. It certainly helps. It's not 100% mandatory, but it's probably the really excellent ones in this field are pretty darn good at math and statistics.
And especially if you want to go to research, then you need to be good at mathematics. So that's the basic requirement. But in industry, it's more of an engineering problem than a research problem. So how to tell your story, how to create a data science model that will be a use case and it will make sense for the industry. It's more of an engineering problem rather than some
and that's a good point, Rod. I mean,
research problem.
Yeah, projects typically don't have 20 data science, right? They might have a few, but they also have a lot of the same supporting roles that a typical technology practice would, like a project manager, a BA, so coders, QA people, right? Certainly there's data scientists doing their part in this, but a lot of times, depending on the scale of the project, we still need a lot of those roles that aren't necessarily data scientists, right? Like we don't need 5 data architects on every project, right? We probably need one with a lot of supporting roles on it. So very similar here with data science.
That all makes good sense. Here's a good one. Can data science be helpful for smaller companies where the data size isn't huge or the decisions aren't financial decisions? If yes, how?
Yeah, I would say absolutely, emphatically yes. Actually, even probably at a greater percentage that it would benefit large companies, especially in a COVID economy, right? Depending on the market you're in. I mean, most of the economy has been down in 2020 because of COVID. What if we could take out the bottom line, just operational expense on any company by 10% or even 20%, right? And that's what's possible with this type of technology. Because remember, this technology doesn't sleep. They don't get sick. They don't take vacations. They can run at scale better than humans, right? So just in terms of cost savings alone, wow, I would say the bang for the buck is actually greater in the SMBs than in the enterprise orgs. Rod, did you have anything else to add to that? I kind of jumped.
Yes, I agree with you. So
yeah.
Well, all right, we're all in agreement on that one. In that case, I believe that's all the questions that we've had in the chat. If we missed something, or maybe you didn't feel comfortable putting your question there, or you'd like to speak with us further, we're here. And that's all for that portion.
Thanks, everyone. Have a good rest of your day. Bye.